In section 7 of this chapter involving exponents and logarithms, we're going to look at some applications that involve modeling. But first, the first few problems that I'd like to look at, I'm going to take right out of our book, involve some research, science-related problems that use logarithms very practically. They refer to example problems in the book, and the first problem I'm going to look at is number 2 in this section, section 7 again, applications, modeling and exponential and logarithmic functions, and it's about acoustics. The problem reads like this. The intensity of sound of a dishwasher is about 2.5 times 10 to the negative 6th watts per square meter. How high is this sound level in decibels? Most people that want to know about sound levels want to know about it in decibels. When you go to a loud concert, you might be hearing the sound at about 100 decibels, which is harmful to your ears. Some manufacturing facilities have equipment that produce sound that is above 100 decibels. It's harmful to your ears, and people wear earmuffs and should wear earplugs to concerts. The equation that helps us to understand this problem is that the loudness of a sound in decibels, that's the letter L, is found by taking 10 times the log of the intensity of the sound in watts per square meter divided by I sub naught. That's how you say it, I sub naught. It usually stands for initial intensity. It is given at 10 to the negative 12th watts per square meter. And our book notes, pays attention to this in the first example, and it says this is approximately the intensity of the softest sound that can be heard. I sub naught represents the softest sound that can be heard in watts per square meter, and it's 10 to the negative 12th. So what I want to do now is, given this problem where I am given I is equal to, right here, 2.5 times 10 to the negative 6th, I'm going to put that in right there. I know what I sub naught is, and I'm going to find L. So L is going to be found by taking 10 times the log of I in this problem, which is 2.5 times 10 to the negative 6th, and I'm going to divide that by 10 to the negative 12th. I'm going to put that in parentheses. I can simplify that without a calculator because I know that when I have like bases, I can subtract these exponents. And a negative 6 minus a negative 12 means that I should add 12 to the negative 6. So I'll get 2.5 times 10 to the positive 6th here in scientific notation. And again, I'm trying to do this without a calculator, so I think I'm going to do pretty good at it. This right here is the log of the product of two things, so I'm going to write that as the log of the sum of two things, the log of 2.5 plus the log of 10 to the 6th. Now, again, from one of the properties, and you don't need to do this, you could have just put this in your calculator and been done with it. The log of 2.5 times 10 to the 6th, as long as you put that in parentheses, then multiply it by 10, you get your answer. But I'm wanting to emphasize the properties. I'm going to bring this down in front, and what I'll have is 6 times the log of 10, where the base is 10. Well, the log of 10 where the base is 10 is 1. So that term right there is a 6. And the log of 2.5, I have checked with my calculator, is 3.398. And those two values right there add to be 6.398. And when I multiply that by 10, I get 63.98 decibels. Now, I've studied sound before substantially because I have a background in engineering, and something like this seems reasonable to me because a person talks at between 40 and 50 decibels at normal conversation level. You know, I'm probably talking a little bit louder. But a washing machine is what we're talking about here is at 64 decibels. You get up close to a washing machine, it's fairly loud. That seems like a reasonable answer. Similar problem to the last one involving sound. It's number 4 in section 7. It's about a jet plane at takeoff. It says a jet plane at takeoff can generate sound measurements of 130 decibels. What is the intensity of such a sound? So in this case, they're giving us the L value, or the loudness, to be 130 decibels. So I'm going to plug in for L, 130, and I'm going to let that equal 10 times the log of I, which I don't know, and that's what I'm looking to find, divided by I sub naught, which is always 10 to the minus 12th. So my goal now is to solve this logarithmic equation for this unknown I. And whenever I have, I'm going to put this in parentheses so you can see that it's a log of all of that. Whenever I have a factor in front and I'm looking to solve an equation, I should divide both sides by that factor so I can just have the equation with the log all alone. So I'm going to divide both sides here by 10. And I'll have 13 on the left equals the log of I over 10 to the minus 12. Now, I'm going to go ahead and write this as the difference because it's the log of the quotient of two terms. So in order to isolate I, I'm going to write this as the log of I minus the log of 10 to the negative 12. And I did that because I knew that I could take this term right here and reduce it down to a natural number. I'm sorry, an integer actually. I'm going to bring that down in front, and what I'll have is a negative 12 times the log of 10, where the base is 10. Well, that's just a negative 12. So I'll be subtracting a negative 12 right there, or adding 12, if you don't mind my saying so. And I'm going to go ahead to save some space. I'm going to put down that subtracting a negative 12 would be that I would add a positive 12. And now I have the log of I plus 12 equals 13. I'll subtract 12 from both sides, and I'll get 1 equals the log of I. And finally, I'm ready to solve this logarithmic equation, which we learned to do in the last section. And I do that by putting this in exponential form, so my base is understood to be 10. So I have 10 to the first power equals I. I'm all done. I would really like you to put the units on that. 10 to the first is just 10. So I would like you to come down here and say that that's 10 watts per square meter because intensity was defined as the intensity of the sound in watts per square meter. So please give me the units. Tell me that that's the intensity. Now read with me and look at one more application, a very good one, and I'm going to reference then after that another one that you should make sure you look at. It's number 14 in section 7. It's about spreading of rumors. It reads like this. The number of people who hear a rumor increases exponentially. If 20 people start a rumor, and if each person who hears the rumor repeats it to 2 people a day, the number of people n who have heard the rumor after t days is given by this function. Now, again, 20 people started the rumor, and it's going to grow exponentially. This is an exponential equation. There are 3 parts to this question, and I'm going to address them individually. I'll just erase each part as we do it. Part A says, how many people have heard the rumor after 5 days? I have written on the right side of the board over here what the letters represent. N represents the number of people that have heard the rumor. So N equals, and it's a function of time. T is the number of days after they've heard the rumor. And in that part where they ask you to find how many people, N, I'm going to write that down here. And given that I substitute 5 days in for T, all I want you to do here is to take 3 to the 5th power, follow order of operations. Your calculator knows how to do this, but if you were doing this by hand, you would take 3 to the 5th power, which is 243, and then you would multiply that by 20, and you'd get 4,860 people. Quite interesting. 4,860 people have heard that rumor in 5 days if it's not stopped. Now think about it. Think about all the rumors that you've heard. It is very interesting, and this is truly how it works. Whether it's forwarding emails on the internet about something that's going on that may not be truly going on if you don't have fact for it. But that's how rumors are spread. This is part A to this problem. Part B says, when will 1,000 people have heard the rumor? So the last problem we put a value in for time and we found the number of people. In part B, it says, here's the number of people. It's 1,000. So the left side of this equation should be represented by 1,000 people. And I want to find out when 1,000 people will have heard that rumor. So I want to solve this exponential equation. Please, as is always true, I want to get this base raised to this power alone. So I'm going to get rid of the 20 by dividing both sides by 20. And in doing that, I'll have 50 equals 3 to the t power. Now I'm going to practice my experience with solving exponential equations, and that involves taking the log of both sides. So I'll have the log of 50 equals the log of 3 to the t power, and then we always brought this exponent down in front, so we'll have t times the log of 3 equals the log of 50. And in order to get t alone now, you're going to divide both sides by the log of 3. So with your calculator, what I need you to do is I need you to take the log of 50, make sure you close the parentheses, divided by, hit the log key. It will open parentheses, put the 3 in, close it, and hit enter. And you should find out that it's going to take 3.56 days for 1,000 people to have heard this rumor. So first time around in part A, we gave you a value for the independent variable t. We said 5 days, find out how many rumors. Here we gave you a value for the dependent variable for n, 1,000 people. How long will that take? And we had to solve an exponential equation. And in part C, very interesting, part C says, what is the doubling time for the number of people who have heard the rumor? Well, if we started with 20 people spreading the rumor, then what they're asking us is when will 40 people have heard the rumor? That's what they're asking for. When they say what's the doubling time? So just like this very problem we just did, but you just have to understand that doubling concept. I want to let this equal 40 on the left-hand side. And interestingly enough, when I divide both sides by 20, I'll get that 2, that doubling feature. And now I'm going to take the log of both sides to solve for t. T will come down in front, and I'll have t times the log of 3 equals the log of 2. And you'll divide both sides by the log of 3 in order to solve for t. And again, on your calculator, if you would hit the log key, it will open parentheses, put the 2 in, close them, divided by. Hit the log key, it will open parentheses, put the 3 in, close it, hit enter. And you should find out that it'll take not even a full day, it'll take 0.631 days for the number of people to have doubled who now know this rumor. This is the last application from this section that I'd like to share with you, and actually it's the close of this chapter. I am going on to another piece, and that is going to be, I'm going to speak with you about some applications that I put into Course Compass that I'd like you to solve involving exponential decay rates of cars and growth rates of bacteria and a problem involving medicine.